Students, before we move on to understand as to what exactly is an electric flux, how much are the field lines, we need to also understand how exactly the charges can be distributed. You will find that not always the charges are point sized. The charges are not placed on a point sized object. The object can be basically quite big in size, or you can have discrete charges spread around the complete object. So in that case, what will happen? In that case, we need to understand about what exactly is the charge distribution. Whether the charge that has been distributed, that is whether it's a discrete charge or it's a continuous charge, how it has been distributed as well. Is there a continuous charge density, or the charge density is also variable? So let's try and understand about the different types of charge densities that we'll be utilizing in this particular chapter.
Now, to understand more as to how the charges are going to be distributed, there are different types of ways the charges are going to exist or they are going to be distributed throughout. We say that we have generally a continuous charge distribution. In a continuous charge distribution, you will have either point charges, or you will have discrete charges, or you will have a continuous charge distribution. So if you have discrete charges, you will say that you have charges like Q1, Q2, Q3 and so on. They are placed at some different points. In a similar manner, you can have charges that is distributed throughout a line. So when we say it's distributed throughout a line, it's uniformly distributed. Similarly, it can be distributed over an area. So the charge over this particular area may be constant. Similarly, the charge over this particular volume may be constant. So in this case, you will say it's a linear charge density. Here you are going to say surface charge density. Here you are going to say volume charge density. Now, how exactly you are going to do it? So now you are not going to be taking them in the form of total Q. Instead, you will be taking, if you are trying to find out the electric field at any point due to these, what you are going to do? You are going to take small charge distributions. So you will say, let's say it's uniformly distributed. So if you take a small portion, let's say here, having some charge, let's say dq. So dq is going to be equals to, further if I say that x is the length of this, so dq is going to be defined as lambda into x, or if I say lambda into dx, that will be more precise. So lambda dx tells you as to how much is the amount of charge. Because lambda is constant, so you are going to put it this way. So you'll say q over L dx. In a similar manner, if you take a small area here, in this particular case, so dq here you'll say sigma into dA, dA being the area. So this can also be written as q over A into dA. In this particular case, for the case of volume, you'll say the total charge dq can be written as rho dV. So this can also be given by q over V dV. So this way, if you are given a continuous distribution of charges, then you are going to use an integration to find out the value of the electric field. Here you are going to take small portions which will have uniform charge density. So you can either it can be linear charge density, or surface charge density, or it will be volume charge density. Let's try to see some applications of this in our forthcoming topics. Thank you.
So we learned about the discrete charges. Discrete charges can be just summed over, but if you have a continuous distribution, you can have a linear charge density, you can have a surface charge density, or you can have a volume charge density. So what basically does that mean? It means that in the case of linear charge density, the charge is spread out over a continuous line. If it's a surface charge density, the charge is spread out over a particular area. If it's a volume charge density, in that case, the charge is spread out over the complete volume. So this is how we talk about the different types of charge densities. We are going to utilize this in our forthcoming topics when we try to understand, using the electric flux, how we can find out the value of electric field. So stay tuned, and I'll come back again with the topic of electric field.